This is the second video on the derivative grapher, and the function f1 has been set up to be a hybrid function with a quadratic and a cubic component. So we go to page 1.4, we see the graph of the function, and there's the quadratic component down to about there. It's then the cubic component. So if we just travel along the graph there until we get to x equals 1, you see the function value is 2 and the gradient is 2. So that's where the two hybrid components meet each other at 1, 2. Notice that the curve there is continuous. We'll just go to the left of that point. Now, needless to say, where the function is cubic, its derivative will be quadratic. And that's what we're seeing down here, this quadratic component up to where x is 1. And of course, where the original function is quadratic, the derivative will be linear. Now let's have a look at what happens as we move the tangent line closer to the point x equals 1. Notice that the gradient is from the left around about 1.43 heading towards 2. If we skip across the point and come back from the opposite direction from 1 point where x is 1.4 towards x equals 1, the gradient heads down towards 2. So that means that the function is actually differentiable at this point x equals 1. And differentiable simply means that the gradient function itself is continuous at the point x equals 1. And you can see that here. There is no jump in this graph as you go from the quadratic to the linear component, or the other way around.